Next one is what? Hysteresis loss. Okay. Hysteresis. So magnetic, we say magnetic hysteresis. Okay. Now, so here we have magnetic material of low hysteresis. We can use how to reduce. This is all reducing. Okay. How to reduce? That is using material of
low hysteresis loss.
Low hysteresis. Low hysteresis का मतलब? Any idea? Low hysteresis means what? भी देखो. Suppose if you say BH curve like this, ये कौन सा है? ये first वाला और second वाला. Just can you? We studied this in magnetic material chapter. This is for what? This is for
ferromagnetic.
No, little. This graph is for hard or soft? Hard magnetic material or soft magnetic material? This one.
Hard.
Hard magnet. Very good. This is of hard magnetic material. And this one is for soft magnetic material. Okay. So we want soft magnetic material. So this is telling about, how much energy is absorbed. Means how much energy is converted to heat energy. That is what he's saying. Is that clear? Now, any doubt you have the flux leakage means what happens around it? There is a magnetic field. That magnet around the coils, there is a magnetic field. That magnetic field may leave the coil. So for that purpose, they are using transformer oil in the transformer. Second is resistance of the windings. Okay, means what? When we use thin wires, there is so much of resistance. So that is the reason we use thick wires. The next one is eddy currents. In eddy currents, what will happen? Eddy currents, as a changing magnetic field is taking place constantly, the heat will be developed in the coils. So that can be reduced using laminated coats. We use turpentine oil and we coat that coil with the turpentine oil, or we say, what is it? Thinner. In simple words, we say thinner. You might have seen thinner. It's like a water, transparent liquid. We apply on that one. So last one is what? Hysteresis. If you are better to use material which are having low hysteresis. Low hysteresis means soft magnetic material. Now we will go with one numerical quickly on this one, and then we'll quickly move to, after that, we'll quickly move to the AC generator. Okay. Now here there is a he says that the efficiency of the transformer in which the 1880 watt of primary power provides 730 on secondary. So power here, he says the power on primary is how much? Power on primary is 1880 watts, and power on secondary is how much? It is 1730 watts. Okay. So what he want? He want efficiency. What is efficiency formula? Efficiency is equal to power, that is secondary power divided by primary power into 100%. Okay. So what do we get? Eta is equal to secondary is 1730 divided by 1880 into 100%. So when you solve it, eta is equal to how much? 92%. This is the efficiency of the transformer. Is this clear, all of you? Is this clear?
Yes, sir.
Going to the next question. A transformer has 100 turns and in its primary. So number of turns on primary is equal to 100. There are 100 turns. Second, and 500 turns on secondary winding. So 500 turns on secondary winding. Okay, if the primary voltage and current are respectively, what is the primary voltage? Vp is equal to how much? It is given 20 volts, and current on primary is 3 amperes. He is asking what is Vs and what is Is. Okay, he is asking what is Vs and what is Is. So we'll quickly go back to our formula. What was our formula? Vp by Vs equal to, what is it? Np by Ns equal to Is by Ip. No one is opening. Let's see. Once again, Np by Ns is equal to Vp by S. So I am going to take, because out of C, if I take these three first, so what will happen? 1, 2, 3. Fourth parameter is Vs. So first what I do is I will take this formula. I'll take this formula to calculate Vs. So now Vp is how much? I'm taking Vp. I want what I want now? Vs I want, right? So Vp by Vs equal to what? Np by Ns implies Vs is equal to what? Vp by Np into Ns. Okay, so what is the formula now? Vs is equal to how much? Vp is how much? 20. Np is 100 into 500. Okay, so 1 and 5. 5 to 10, 100 volts is the answer. Is it clear? 100 volts. 500 by, sorry, it is 120, not 20. It is 120. Sorry. So if you multiply here with 120, 120 into 5 becomes 600 volts. Next one. We will use, now we can use anyway. So number of turns on primary divided by number of turns on secondary is equal to Is by Ip. I want to find out Is. Is is equal to Np into Ip divided by Ns. So Is is equal to what? Np. Np is 100 and Ip is equal to how much? 3 divided by Ns. Okay, divided by Ns is how much? 500. So this will become 5. So answer is how much? Is is equal to 3 by 5, which is equal to how much? 0.6 amperes. Is it clear, all of you? Is this clear?
Yes, sir.
Okay.
Yes, sir.
We'll start with the principle first. What is the principle of AC generator? Principle is a device to convert
DC to AC.
To convert mechanical energy to electrical energy. Okay, mechanical energy to electrical energy. Okay, that is DC to AC is inverter. DC to AC is inverter. See, we should be clear with these things. One is rectifier. Okay, one is rectifier. One is oscillator. One is inverter. Rectifier means it is converting AC to DC. Example for this is adapters. Okay, example is charger or adapter, whatever it is. Oscillator or frequency generator. Okay, oscillator means or frequency generator. Frequency generator, what we say means it converts DC to oscillations or AC. We say AC oscillations. Okay, AC oscillations. One second. Hello, ma'am. Yeah, good. Now inverter is what? Inverter is converting DC to AC. What is this actually? I will tell you. In India, there is a power fluctuation. In India, we have more power fluctuation, especially when you go to district areas or villages. The problem is there will be a big inverter. Inverter means a big battery. There's a battery, there is an inverter. So what we have done is, first of all, what it does is it converts. There are two things. There is a rectifier, there is an inverter in that big box. Rectifier, whenever the current is there or the power is there, the current is converted from AC to DC and stores in the battery. In battery, we cannot store AC current. We can store only DC. So it converts from AC to DC, and that charge is that energy is stored in what? In batteries. When the power goes, what happens? Inverter comes into action. What happens? DC, that whatever the energy is stored in the battery, it converts DC to AC and it supplies to the tube lights or the fans wherever you have fixed this. Okay, means with inverter we are not going to light the whole house. If you do like that, then within 1 hour it will drain. The battery will drain, and it depends on the size of the battery also. Okay, the more batteries, the more time it can work. Okay, so that is the difference between a rectifier, oscillator, and inverter. Is that clear, all of you? An amplifier means it amplifies the signal. It should be clear with all these four. Amplifier means it amplifies the signal. Amplifies the signal. Means what type of signal? Any signal. Okay, it can amplify voltage signal, current signal, power signal, whatever it is. Okay, we have voltage amplifier, current amplifiers, and power amplifiers. Mic is also amplifier. The microphone is an amplifier. It amplifies the signal. Okay, now, so this was about the principle behind it. Please note down somewhere this one. Then I will erase this and I will draw the diagram now. This is rectifier, oscillator, inverter, and amplifier. Please note down somewhere. Done. This you can copy later. First we copy this rectifier, oscillator, inverter, and amplifier. Okay.
Yes, sir. Done.
Okay. Then I'm erasing this one. Now, after that, we'll have see what is the principle, construction, working, then uses, and factors on which it depends. This is how the AC generator goes. Even the motor also. See, we have electric motor, electric generator. In motor, what is a motor? Motor is converting electrical energy to mechanical energy. We have two types of motors. One is DC motor, one is AC motor. Okay, example for DC motor is what? The the motor in the cars or like toy cars. In the toy cars, we have DC motors. AC motor, the grinder, okay, grinder, or we say washing machine, or ceiling fan, okay, table fan or ceiling fan, whatever it is. And water pump, okay, water pump. These are all the examples of AC motor, water pump. These are all the examples of AC motor. Second one is what? Generator. What is generator? Generator is converting mechanical energy to electrical energy. Now in that we have again a DC generator and AC generator. AC generator is the grid, okay, the grid from where the electricity is produced. Okay, this is what we have generated. The grid, electricity generated somewhere at a point. From there it comes to our offices and home. So that is how we are consuming it. Now this and DC generator. DC generator is in simple way we use this, in the labs, mostly in medical labs. For MRI, X-rays and MRI, X-ray for X-ray and MRI, magnetic resonance imaging, PET scan, what do you call CT scan. Okay, CT scan. For this purpose, we need a high DC voltage, not the AC. We don't need AC. We need a DC. So DC with that also very high. So for that reason, we cannot use AC current. We have to use a DC generator. Okay, there it is there. So the setup, in that setup it is there. Please copy this one. Then we can quickly go to the next one also. Somewhere you can copy this. Difference between a motor and generator. In motor also two types of motors. And generators also two types of generators. So in grade 10, I think there was only AC generator. I think AC or DC. I don't remember. No, sorry, motor. DC motor or AC motor. I don't remember.
I think it was DC.
DC motor, maybe I don't remember. And even in generator also was there, but generator they removed from the syllabus. I think in grade 10.
Yeah, sir. They removed
Yeah.
it.
Done. Can I erase this and can I start with the construction? Yeah, are you clear with the terms now? What is
Yes, sir.
What is rectifier? Rectifier, oscillator, inverter, amplifier. These are all different. Okay. And motor and generator also. And again in DC, AC, DC, AC. This is the classification. Okay. Should be very clear with the terms. Okay. There is no DC generator in your syllabus, only AC generator. Okay. Actually, they should have put AC motor also. Where AC motor in this and DC motor in magnetism and matter there. Now, so now, can I erase this now? Yes?
Yeah, sir.
Okay. Then I will go with the construction. The construction, then working, then we can go with the applications. So I'll start with the construction. So construction. What is there in construction now? Suppose I'll just draw here. So here, what will happen now? There is a coil. There is a coil here like this. Okay. This is north pole and this is south pole. Okay. Now, here what happens here? And here also it's the same. This is connected here, and this one, the other one is connected here at this point. Okay. I'm just drawing it here. Like there's a metal brush here actually. There's a metal brush here. Now these two are connected to what? These two are connected to here. Okay. So this is what? Slip rings. These two are slip rings. And this is a coil. This is a coil, and so this is axle. And this is alternating EMF. Okay. This is alternating EMF. Alternating EMF, and these two are carbon brushes. Okay. These two are carbon brushes. These two are carbon brushes. Okay. So these two are slip rings. Okay. In motor, we have commutator rings. Means one ring is broken into two parts. But here we have two rings. That is two slip rings. One here and one here. Okay. So here we have carbon brushes, and these are the two wires. This is alternate. Now this is a coil, and there is an axle, and this is a north and south pole of a magnet. Okay. Now if you see carefully, now this is about the construction. How it works now? So there is a magnetic field here, and we have to rotate it actually. There is no current here. We have to rotate fast. How do we rotate? See, in India or anywhere, we have different types of grids. Number one, we have hydroelectric power stations. Hydroelectric power station means what? Water. Water is stored in the dam, and that water is made to move on the turbines. When the turbines rotate, then electricity is generated. This happens in India or wherever we have dams. Okay. So the next one is thermal power stations. Thermal power stations. What are thermal power stations? Here we can use coal, oil, and natural gas. Coal, oil, natural gas. So Qatar is supplying natural gas to most of the countries. Even Sharjah has natural gas. So electricity in Sharjah, Qatar, and all generated by natural gas. There are a lot of gas. And oil, Dubai, Abu Dhabi, many oil-rich countries like Saudi Arabia and all, they are using oil. Okay, like petrol or diesel. They burn that and they generate electricity. In India, we have coal. Okay, sorry. In India, we have coal. So we burn the coal and we generate the electricity. So the next one is nuclear power stations. Okay, in which nuclear we are using nuclear one. Or it means we are using uranium and nuclear reactors we are using for this purpose. Now we have wind turbines and all, but they cannot produce that much electricity. Now what happens is we are burning in simple words, if you see carefully, we are burning the water in the turbine. So this is the water. This is the container. There's a lot of water in the big container. This is very big, huge container. Now, so what happens? The current is once you heat it, for which you can use oil here, you can use coal here, you can use natural gas, whatever is available, you burn that and boil the water. And when you boil the water, what happens? Steam comes out with very high pressure. This is steam. Okay, steam comes out with very high pressure. With this pressure here, there is a turbine. Okay, turbine means what? If you see the aeroplane engines, you have a big fans like blades. There are so many blades. Have you seen that anytime? Aeroplane engine, if you see, there are so many blades. One blade like this, in this way. I can say in this way. Blade on blade, blade on blade. Okay, if you see carefully, there are so many blades. So when the high pressurized steam will go and hit the blades start rotating. And there is a common axle. This is the axle. The axle starts rotating. And here there is a magnet. Here this is a magnet, North Pole and South Pole, and on which there is a coil mounted. This is a coil mounted. So what will happen? When this turbine rotates, the turbine and the coil are mounted on the same axle. When turbine rotates 50 times, the coil also rotates 50 times. Is that clear? When the turbine rotates 50 times, the coil also rotates 50 times. So when it rotates 50 times and cutting the magnetic lines of forces so fast, electricity is generated. Is that clear? Once again, here depends upon the availability of the resources. So they burn coal or oil or natural gas and they boil the water. When you boil the water, you know, the steam comes out with very high pressurized steam comes out and it rotates the turbine. The turbine and the coil are mounted on the same axle but separated with something so that the water should not go inside. So when these rotate 50 to 60 times, this also will rotate, the coil also will rotate 50 to 60 times, and it is cutting the magnetic lines of forces. When it is cutting the magnetic lines of forces, current is induced or current is produced. Okay, so our induced current is produced. That is how it works. So same thing, we are, instead of drawing the whole thing here, only we are drawing the last part. See, are you understanding now? We drew only the last part here. This thing is avoided actually. Got it now? Is this clear, all of you?
Yes, sir.
So now what happened is, I'm erasing this. If you want, you can draw somewhere, otherwise leave it, this part. If you want, you can draw this one. I'm going to erase this now. Now, now here what we have, pi is equal to what? We have the formula. Pi is equal to, okay. So we have the formula here. So phi is equal to what? B into A cos theta. The formula is phi is equal to B into A cos theta, or B dot A. The flux is B dot A cos theta. Okay. Now, or we can also write phi is equal to what? B into A cos omega t. B into A cos omega t. So here E is equal to what? We can write E is according to Faraday's law of electromagnetic induction. According to Faraday's law of electromagnetic induction, we have E is equal to minus n into d phi by dt. Okay, rate of change of magnetic flux induces current in the conductor. Now, what I am going to do now, you know, phi is equal to B dot A. So what I am going to write, E is equal to minus n. Phi is what? B into A cos theta. B and A both are constants. B and A both are constants. D by dt of cos omega t will be left. So E is equal to what? Minus n B A omega sin omega t. Cos is minus sin. So minus of minus will become plus n B A omega sin omega t. This is the formula. Now we can also write E is equal to what now? The formula will be E is equal to E0 sin omega t now. Okay, the induced EMF is E is equal to E0 sin omega t now. Okay, is it clear, all of you?
Yes.
Yeah.
Yes, sir.
What is omega again? Omega is equal to, we can write 2 pi nu. What is nu? Nu is number of rotations. How many times it rotates in the presence of magnetic field? How many times it rotates in the presence of magnetic field? That is nu. Is it clear, all of you?
Yes, sir.
Yes,
Okay.
sir.
So, so this is the working. Okay. So principle, construction, working. So what is the use of this? To produce electricity to the country or to the society. Okay. For this purpose, we are using uses of this is to produce electricity. Okay. To produce electricity to cities or towns or whatever it is. To that we supply the electricity using this concept. What are the factors on which it depends? It depends on the number of rotations. Okay. Factors. It depends on N, it depends on B, it depends on area, it depends on the magnetic field, number of turns, area, and the rotations. Okay, how fast it omega also. So it depends on all these. These are the factors on which it depends. Now, is this clear? So what will happen for one cycle? Let me explain you for one cycle. So now suppose this is one cycle. What is happening for one cycle? See here, this is quarter cycle. Again, quarter cycle, and quarter cycle. 0, 90, 180, 270, and 360 degrees. Okay. So this is the 4 quarters of a cycle. Now what happens? So what happens here in this case? In this case, 0 to 90, what is happening? The coil is turning from C. It was like this in this way. The coil was like this before in the presence of magnetic field, like this. These are the 2 magnets. The coil is like this. Now what happens? The coil is rotating. How? It is like this. It is rotating like this. 90, 0 to 90. What will happen? The shape of the curve will be like this. It goes from 0 to maximum because there is a maximum torque here. Maximum torque between the 2 magnetic poles of the magnet. Now again, when it comes from 0 to 90 to 180, it will become like this. Again, when it is 180 like this, when you rotate it to 270, it will become like this, negative, and becomes like this, it becomes again 0. So that's what happens in one cycle. Is it clear? Is it clear, all of you? So this complete happens in one cycle. Okay, so this we can write, it is how much? 0. We can write t by 4. This is t by 2. This is 3t by 4, and for one time period, time taken to complete one oscillation or one rotation. Now, so we have uses, we have factors. So better we are harnessing electricity from most of the countries. They want to harness electricity now, not on hydroelectric and coal, especially because coal, oil, or natural gas, when you burn, there's a lot of smoke or pollution, or it gives rise to global warming. So that is why most of the countries want to switch to nuclear resources. Okay, even UAE, we have Baraka nuclear plant, which is in Baraka, Abu Dhabi. So they have switched to because they want to reserve the oil now. They want to save the oil for the future generations. So for even to save the planet also.
So, but nuclear is also not good for the environment, right?
No, it is good. See how it is, I will tell you. The nuclear power plant, we have uranium. We use the uranium as a fuel. So we, we have fuel rods over there. Fuel rods, we use the fuel rod for some 3 months, 6 months, 1 year, depends on the size of the nuclear reactor. So once it is used, the fuel rod, we cannot throw it. Only the problem is with the fuel rod, we cannot throw it. And now the safety precautions have increased. Safety is increased. Now earlier, some 40-50 years back, there were 2 explosions. One is in Chernobyl, which is a part of Russia and Ukraine. So in that there was a big explosion and many people died. Around 180 something people died due to the leakage.
Yeah, so they're radioactive and very toxic.
Yes, sir.
Yeah, the same thing happened in California also. So that is why people were scared. Now we have high-end facilities. Okay, if there is leakage, is there auto off is there. When the leakage crosses a certain level, you need not even cross. Automatically it will switch off. So that type of facilities they have made. So now it is a lot of safety has come into line. Okay, no manual thing is to be taken. Okay, so that is one. And one more thing, in France, 90% of electricity is coming from nuclear reactors only. Okay, so most of the countries, they want to go slowly to the nuclear reactors. That is good also. The only thing is about the availability of the uranium. And in the ships, huge cruise ships like Evergreen, you might have seen big cargo ships or cruise. So they don't run on diesel or petrol. They run on nuclear reactors. They change the fuel rods once in 5 years. You know that they don't run. You don't see any smoke when the big ships or big cruise or cargo ships they travel. There is nothing like that. They don't run on, but we need a fuel.
Oh.
Yeah, there are motors. There are big motors inside it, but they don't run on coal or oil or this one, natural gas. They run on, because that much electricity has to be produced to run the engines. Okay, clear?
So we don't have to think about oil spills and all.
In future, yeah, but we have to, the problem is the safety, we have to preserve, and these fuel rods you cannot throw wherever you like. This is a big problem with every country. So this has to be kept in big.
So disposal needs to be taken.
Disposal means we have to keep it in a big containers. Containers will come. These fuel rods are kept in lead containers, and they are saved somewhere, buried inside the ground somewhere. No one knows about it. This is completely confidential for every country. So they keep it first. They place it in the lead containers and place it safely inside, bury somewhere in the ground. So in future, research is going on how to reuse that fuel rods also, but it will take some time to bring in practice. Okay. So this completes your lesson.